Okay, so let's see if we can finish this problem without any technical difficulties with my iPad here. Okay, so this is our general function, right? Our general solution to the differential equation. We found our C, and we haven't found our K, so that was the next step. So let's go ahead and find our K, and we're going to use our other condition that we haven't used, right? We know after 10 seconds, right, the velocity of the car was, I think it was 100, right, kilometers per hour. So let's go ahead and use this. So I get V of 0, or V of 10, is equal to 250 minus 250 e to the negative kt, and so that's going to be just negative 10k, but this guy is going to be 100 equals 250 minus 250 e to the negative 10k. Now remember what our goal is. Our goal is to, at this point, is to find k. So again, this is just a college algebra equation. I'm going to go ahead and subtract both sides by 250, and then we obtain negative 150, negative 250 e to the negative k. These guys become positive, and I can divide by 250, right, because I want to isolate the right-hand side as much as possible. This is just a big 1. It's a 1. 15 25ths is 3/5 equals e to the negative 10k. We're ready to natural log both sides. And this is really, right, 3/5 is 0.6. This is my power, so I know it's going to, because I'm working with a logarithm, I can bring it down. This is gone. And, right, so we have k is equal to negative 1/10 times the natural log of 0.6. And if you punch this guy in your calculator, you're going to get an irrational number, right? It's not, I mean, you can't write it as a fraction because you get an irrational number. So it's a non-repeating, right, really ugly decimal. So we actually want to keep our k as follows. Okay, so we found our C and we found our K. So let's write our solution to our differential equation with all our findings here. So we have, let's see, where is our original? Okay, so it's this guy right here. And we notice, actually, I'm going to go ahead and factor out a 250, right? Because we have a greatest common factor. So I'm going to go ahead and factor it out. And let's see, I'm left with 1 minus, let's see, we have e to the negative kt. Okay, so let's work with this guy. Again, same thing, it's just in factored form. And you'll see why I did that. Just makes it a little bit easier to work with. Okay, so let's use our information. So we have, okay, 250 times this quantity, and we have KT. So what was our K? Our K was this, where is it? Oh, it's right here. And maybe it's right in pink. So that's our K, which is a negative 1/10 times the natural log of 0.6. And we have, okay, so this is our V of t. Okay, so it's a function of t, and I forgot my t here. It's a function of t. Okay, so what is the question asking? Remember, our goal is to find when will the car reach a velocity of 200 kilometers per hour? Okay, so when, well, I mean, we're looking for that t, but we want the velocity to be 200 kilometers per hour. So 250, and I'm just rewriting everything here, natural log 0.6, and we're trying to determine our t, right? This is our when. So now we just have to solve this equation for t. Again, a nice college algebra equation. Notice because I factored that 250 out, I can do this. All right, that's a big one. Well, those are going to cancel anyway. 25ths is 4/5, right, or 80%. And then we're left with this guy, 0.6. Well, we can write t. Let's see, now we can, just do some more algebra here. So our goal is to solve for t. So let's see, I'm going to go ahead and I can subtract both sides by 1. Right, if I do that, right, if I do -1, well, if I subtract 1 here, I'm really subtracting 5/5. So this guy's really negative 1/5. And let's see, I'm left with negative e to the negative 1/10. Right, so you just have to be careful with all these, I mean, you're just manipulating this. This is positive, right, because they're both negative. And let's see, what do we have next? We can take the natural log again of both sides. All right, we're allowed to do this, right? That's really just a plus sign. And the reason I'm taking the natural log, so ln of, again, this is really 0.5, not 0.5, just kidding. It's 0.2, it's 20%, right? 0.5 would be a half. And I'm doing this because, right, I mean, this is nice, so that means all of this really comes down here. So I get negative 1/10 ln of 0.6 t. And this is great because t is going to equal ln of 0.2 all over negative 1/10 ln of 0.6, right? Or you're really multiplying by -10. So that's pretty much it. So let's go ahead and I'm just going to hit pause and I'm going to punch that in the calculator. And we get about, so we can just approximate here. So 31.5, right? And we're in seconds, right? So to answer our question, when will the car reach a velocity of 200 kilometers per hour? At 31.5 seconds. And I mean, you can go ahead and graph. It doesn't ask to graph it, but you can go ahead and graph your solution, right, to the differential equation, and then you'll see, after what it was at 31.5 seconds, it's going to reach its maximum velocity. Okay, so that is the end of number 1 in section 1.8.